All right, so I'm sure you are just absolutely thrilled to spend some time with me on this video, getting ready for our next assessment. We're going to review stuff about chain rule, a little bit of product rule, quotient rule, implicit derivatives, logarithmic differentiation, all sorts of interesting little pieces. So let's get a couple of them out of the way right now. I decided to do a different review than I've done in the past. I actually found some nice questions online that actually the first few are multiple choice. And I decided this year I'm going to have some of those kind of problems on your exam. Be very, very careful on multiple choice. This can be dangerous. You don't ever want to just look at the questions to find the answers. You always want to make sure you do your due diligence and actually do the questions. So notice that we have this idea that I'm going to take the sine of e to the 3x, and it's telling me that I want to take the derivative of that thing when I square it. So remember, chain rule says the first thing we're going to do when we take that derivative is we would take the 2 down to the front, and we would have then raised it to the first power. I could write that 1. I don't have to write the 1, but what I kind of tend to like to do is I like make a little checkbox. So I took care of the square. So now I'm going to work my way chain rule in towards the middle. And now I need to take the derivative of sine, which of course we know is going to be the cosine. We leave that interior piece alone. I took care of this. Now I need to go inside and take the derivative of e to the 3x, which of course is e to the 3x. And I took care of the e part. But now I got one last piece, which is the derivative of 3x. Which is 3. So a quick bit of simplification would be 6e to the 3x times the sine of e to the 3x times the cosine of e to the 3x. And as it turns out, that actually is sitting right here, giving me answer A. But you should kind of always have that suspicion whenever you see this, because what someone could have done is we could have used the double angle identity. That if you ever have this story, we could do that. So I could have rewritten the sine and the cosine like this as the sine of 2e to the 3x. I would have stolen one of these 2's from the front because there's a 2 right here, and it would be 3e to the 3x. I actually think this is a stronger answer for that problem, but in this particular case, we chose not to do the double angle identity. So we're all right. Okay, next question. Now, again, this one is not a chain rule question. This is really just a nice quotient rule question because I want to know where the horizontal tangent happens. And so, of course, we're going to take our derivative. As always, it is calculus. We're always going to take a derivative, but we're going to find out when the slope is 0. So we'll find out. So let's do a little low d high. So my low is x plus 1. D high is e to the x minus the high, which is d low, and the derivative of what's below is 1. And then, of course, it's x plus 1 squared. So there's my low d high minus high d low over the square of what's below. Now, of course, in this particular case, if I took just a few moments to simplify it, distributive proper would give me e to the x times x plus e to the x minus e to the x all over x plus 1 squared, which clearly those two things cancel. And so it all comes down to this story right here. And in this particular situation, they're asking, where is the slope going to be 0? Well, the only way that a fraction can ever be 0 is if the numerator is 0. And when you look at e to the x is a graph that looks like this, and it can never be equal to 0. But of course, the number x itself can be 0 if x itself is 0. I noticed that I just completely ignored the denominator because I did not need that little piece of data at all. And so I think I'm going to stop right there. We're just going to do the first 2 questions on that one, and I'm going to go ahead and start another video here in a few minutes. Okay, bye-bye. Hopefully that was helpful.